I'm going to start this proof by labeling my diagram based on my givens. From there, I'll add anything I could add that's not a given, but something I could assume, things like vertical angles, shared sides. I'll kind of set up a plan for what shortcut I'm going to use, and then from there, I'll actually write the proof. Before I get started, right away though, I notice that I'm trying to prove that two angles are congruent, not that two triangles are congruent. So I'm going to first show that two triangles that these angles are in are congruent, and then I'll use CPCTC to say that corresponding parts of congruent triangles are congruent. So let's start by labeling what we know. We're given that segment ZA is congruent to segment XB. So I know these two segments are congruent. And my other given statement is that triangle WZX is an isosceles triangle with vertex W. Well, an isosceles triangle is a triangle with two congruent sides, and those congruent sides are going to be the sides that touch the vertex. So if W, that point up top, is the vertex of the triangle, these two sides are congruent. I eventually want to show that ZWA, so this angle up at the top, and XWB are congruent. So I'm going to start by showing the two triangles that they are a part of are congruent. So for now, let's kind of ignore this chunk in the middle. We're trying to prove those two skinny triangles on the side, so triangle ZWA and triangle XWB are congruent. Right now I've got two sides, so I need to find one more thing in order to use a triangle congruent shortcut. I can't use SSS because I can't show that the two sides are congruent. So I'm going to try and find an angle somehow. Well, if you'll remember back to section 4.6, we know that in an isosceles triangle, the base angles, so the angles that don't touch the vertex, are congruent. You can either call that the isosceles triangle theorem or the base angle theorem. So from that, I've got two sides and an included angle. My shortcut is going to be SAS, and then from there, I'm going to use CPCTC. So now that we've got our plan, let's actually do it. First thing I have to do is show congruent sides. Well, one of my given statements tells me about congruent sides. It's that segment ZA is congruent to segment XB, so I'm going to start with that. Next thing I have to do is show my angles are congruent. You'll remember from when I labeled my picture, though, that I didn't know that right away. That wasn't one of my given statements. First, I had to know that the triangle was isosceles. So let's get that into our proof. I'm going to say triangle WZX is isosceles with vertex W. That told me two things. It told me that I had sets of congruent sides, and it told me that the base angles were congruent. So actually, I think I'm going to work a little bit out of order just because this is the order that I labeled things in my picture. Since the triangle was isosceles, I knew that segment ZW was congruent to segment XW. I'm going to say my reason is definition of isosceles. So now I've got another one of my sides taken care of. So I'm going to jump back up to my plan and I'm going to cross out one of my S's, but I've still got to show that angle. So I still have to say angle Z is congruent to angle X, but since we know the triangle is isosceles, we can do that. My reason is the isosceles triangle theorem. You could have also called it the base angle theorem. You should have this in notes from section 4.6. The isosceles triangle theorem says if a triangle is isosceles, then the base angles are congruent. So now we've got that A taken care of. Now that we have SAS in our proof, we can say the triangles are congruent, and then we can use CPCTC. So step 5 for me is that triangle ZWA is congruent to triangle XWB. By side, angle side. I showed that in steps 1. My angle was in step 4, and my other side was in step 3. Again, if you forget those parentheses or if you get the order mixed up, it's not the end of the world. That's just there to keep us organized. And now that I know that my triangles are congruent, I know that those corresponding angles will be congruent as well. So my last step is always what I'm trying to prove. That's that angle ZWA is congruent to angle XWB. The reason is that corresponding parts of congruent triangles are congruent. And that's a C. It looks kind of like an O.